Hello everyone. Okay, now this is section 4.4. Um, as usual, before I start the lecture, I just want to remind you guys about the web assigned homework again. Um, the web assigned homework of section 3.9 and 4.1, 4.2 is due this coming Saturday, which is October 17. And okay, so last Thursday you guys took exam 7, and now we are right now here. Technically, I skipped section 4.3 right now. So, okay, so that means your exam 3 is coming pretty soon. All right, so that means it's going to be 2 weeks after this lecture, which is Thursday lecture. All right. So I'll talk more about the exam 3, but I'm just reminding you guys about the exam 3 at the moment. All right. Okay, let's start this section. Okay, so we are right now, well, we are doing integration, right? So the integration, basically this 4.4 is about indefinite integral. All right, so indefinite integral, we write it like this, where there are no intervals. Okay, so the last lecture, I think it was Monday lecture, I showed definite integral, right? So where on the definite integral there was the interval, but in this one there is no interval. Okay, so basically it's pretty similar to what I talked about the antiderivative, uh, the very first lecture of antiderivative, which was I think last week. If you guys have watched my whole videos, probably you guys know what I'm talking about. So antiderivative and integral is basically the same thing. Now, whatever I did back there in antiderivative, it's pretty much exactly the same thing. Now we're just introducing this sign here. All right, so this sign is indefinite integral. All right, so I pretty much explained this before, but I'll really quickly go over this. So when you're taking the integration of constant times some function, then I can just bring it out the constant, right? Or if you're just taking the derivative of constant, let's say k is also constant, then that will be kx plus and c. Similarly, if you take the integration of a sine, then it will be negative cosine. If you take the integration of cosine, it will be sine. So basically, yes, these are the formulas. You can take this as a formulas as well, right? So we will be using this formula when we do the actual problem. I'll just do a few examples just to show an idea how does it work. I think you all know by now how does it work, but still there are a few examples where you need a few tricks. Let's start with the simple simple one first. So when you take in the integration of this one, basically there is 3 minus this, so I can basically distribute like this, just like I did in the last lecture, minus integration of x to the power 7 dx. All right, now last lecture we had interval. Right now we don't have an interval, so when you have an interval, it's a different approach, slightly different approach. But here, when you take the integration of a constant, it will be 3 times x, right? That's what I said here, right? When you're taking the integration of constant, that constant times x plus c, right? But we can write that plus c. Well, c is a constant here again. We can write that plus c at the end. We can just write one constant. Or if you want to write a constant, you can still write a constant here. Or let's just say plus c, or let's just say c1 in this case. C1 is also constant. Let's assume c1 is also constant. All right, minus. Now if we take the integration of x to the power 7, it will be x to the power 7 plus 1, right? Over 7 plus 1. Okay, and plus c. Okay, or c2. Now, since you are saying these two are constant, so if you add two constant, you will still get a constant. If you add c1 plus c2, well, these two are constant. Basically, if you add any two numbers, you will get a number, right? We don't know exactly what the number is, but we're just assuming it's a number, some number. So it will be a number, which let's just say C. All right. That's why I said you don't have to write C1, C2 every time. You can just write plus C at the end, but you have to write plus C. Don't forget that. All right. It's pretty important. Okay. So from here, you get 3x minus x to the power 8 over 8 plus C. Okay. So yeah, this is how you take the integration. Okay. Now let's do this one where you have a trig function, right? So just like I did before, you can distribute. So integration of x dx minus integration of 12 sine x dx. Now the integration of x is also x square, which is 1, x to the power 1 plus 1 is x square, right? Over 1 plus 1 is 2 minus, well, this is a constant. You can just bring that out. Just take the integration of sine. So what is the integration of sine? It's a negative cosine, right? When you take the integration of sine, it's a negative cosine. So it's a negative cosine x. And at the end, you can just write 1c. Okay, now here this minus, you can write plus. So 12 cosine x plus c. Okay. Okay, now what about this one? Okay, so now you might think, okay, you take cosine x divided by or integration of cosine x dx or sine square x dx, right? You might think you can do that, but no, you cannot do that. You can only do that if you have like this where there is plus minus, you can distribute. But here, no, with this one, that's not possible. That's not possible. All right, so here's a trick. Let's use some fact from uh, some fact from uh, trigonometry. All right, let's use the fact from trigonometry. So what we can do here is basically we can say that, okay, we can say cosine x, and we can say sine square x is also sine x times sine x, right? It's the same thing. Okay, now after this, what I can do is, well, I can just say, okay, I can just say 1 over sine x times cosine x over sine x, right? Well, I haven't done anything. I've just arranged these things. So 1 over this times, well, these two are exactly the same thing. Well, I haven't done anything here. It just, these two are exactly the same thing. I've just arranged it so that I can compare some of these to the thing from trigonometry. All right, so what we can say from trigonometry is that, well, 1 over sine x is cosec x. Well, that's a fact. If you guys took trigonometry, then probably you should know it. All right, and also if when cosine x over sine x is cotangent x. All right, so that means this one I can replace this one by 1 over sine by cosec x, and cosine x over sine x, we can replace that by cotangent x and dx. Right now, okay, so when we see this, it looks something similar to what we have from our formula. Well, cosine, yep, cosine x times cotangent x, and when you take the integration of that, it's negative cosec x. Right, so yeah, there you go. So this is negative cosec x and plus c. Okay, so yeah, you just have to play with this. Just from here, it's difficult to take the integration. Well, it's not possible to take the integration, but when you arrange this like in this form, then we can see we can change this to this, we can change this to this. So from there, we actually got a form where, or we can compare this to, or we know this is a formula. So from that formula, we just got our answer. All right. So sometimes you have to play with the problems. You have to see and try different method that you guys already learned from your previous classes. All right. Okay, so now with this one, what we can do with this one? Well, we know that if we have a plus b over c, then we can even say this is as a over c plus b over c, right? We can write this one like this. So we can do same thing with this one, since this x square is well, you're dividing this x square to all of these, right? We have plus minus here. So what we can do here with this one is, I can even say this is 2x square over x square plus square root of x over x square minus 1 over x square, right? And dx. Okay, now after this, we can take the integration of each of these, right? But before that, well, it looks like x square cancel out. 2. Well, what we can do with this one? What we can do with this one? Let's do that one here. So we know that x square root of x, we can also write x to the power 1/2, right? So that means we can say with this one. So that means, okay, so square root of x means 1/2. So 1/2 over x square is also same as, if you move this to the top, then it will be x to the power 1/2. And if you move this to the top, it will be minus 2, right? Okay, so from here you get that, okay, 1/2 minus 2, you get, okay, 4. 1 minus 4 is x to the power negative 3/2, right? So that means I can write, well, I can replace this whole thing by x to the power negative 3/2. And similarly with this one, when you move this to the top, it will be x to the power negative 2, right? So, okay, now let's take the integration for each of this. So, okay, first let's take the integration of 2. I'm not gonna write that distribution thing. I'll just directly take the integration. So if you take the integration of 2, it will be, or if you take the integration of constant, it will be that times, since we are taking the integration in terms of x, so x, right, plus x to the power, okay, we have this whole thing, negative 3/2 plus 1, right, plus 1 over same thing, right, and on the bottom, negative 3/2 plus 1. Similarly, minus minus, x to the power negative 2 plus 1 over negative 2 plus 1 and plus c, right? So constant. Okay, now after this, just do the algebra thing. So 2x, okay, so negative 3 plus 1 is also, well, that's negative 1/2. So that means on the bottom, you're also going to get negative 1/2, right? And negative, so x to the power negative 1. And here negative 2 plus 1 is negative 1 plus c. Okay, now what? So, well, this negative, 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 we can write that positive, right? And this positive, this negative, we can write this negative, all right? This negative, so this will be positive, right? Okay, now, well, this 1/2, this divided by 1/2, that means I can move this 2 to the top. So 2x minus 2x to the power 1 power negative 1/2 plus, well, I can move this thing to the bottom, which will be 1 over x to the power positive 1, or just 1 over x plus c. What else we can do after this? Well, this is just algebra, all right? So, so after this, after this, it looks like I can move this to the bottom as well, just like I did here. But this will be positive, so it will be a square root on the bottom, right? So from here, we'll be getting 2x minus 2 over square root of x. Right, you get this, right? So if you move this to the bottom, it will be, if you move this to the bottom, it will be 1 over x to the power positive 1/2, right? And x to the, again, this x to the power 1/2, I can also write square root of x. So that's why we'll get 1 over square root of x. All right, that's what it is from here. Now plus 1 over x plus c. Okay. So yeah, these are the few tricks you need to use on some of these problems. Later on, next chapter, I will be introducing the substitution rule. All right, so yeah, I'll talk about that on the next lecture. But for right now, what I want you guys to do is I want you guys to do this problem. Let me just assign this as a quiz. All right, so this is a quiz problem. So integrate all right, so integrate this based on whatever we have learned so far. All right, it shouldn't be too hard. I just want to check whether you guys are watching this videos or not. All right, so all right, that's the quiz, and so that means since this is a Thursday lecture, so that means the due for this quiz is going to be tomorrow, Friday, right? Which means October 16th, I guess. Yeah. So yeah, whatever. Next day. This is Thursday lecture, so next day, Friday, is due for this quiz. All right, that's all I have for this lecture. I will see you on the next video. All right. Yeah, thank you.